This video is going to cover how to solve exponential equations with two different ways. So the first way is going to be with the same base. The second method will be with a different base. Okay, so just to kind of remind you what a base is, and you don't have to copy this part down. Let's say we have 3 to the x equals 3 to the 4. Okay, so this right here, this 3, this is the base. Okay, so the base on this side is 3. The base on this side is also 3. Okay, so same base refers to, I'll just kind of bubble this on the side. Same base refers to these two numbers being the same. Okay, so the good thing about same base is that it's really simple with the fact that you don't have to really change much. So we're going to go right into an example. Okay, have 4 to the power of x minus 2 is equal to 4 to the power of, we'll make it simple, 3. Okay, if the bases are the same, all we need to do to solve for x is figure out what number goes here that will give me this 3 over here. So in other words, we just have to set the exponents equal to each other. So we're going to set the exponents equal to each other and solve for x. Okay, so this is the key thing for solving exponential equations with the same base. So in this case, all I'm going to look at is x minus 2 and 3, and I'm going to set them equal to each other. So it'll look like this. X minus 2 equals 3. Okay, and we solve. So this is a simple one-step equation. We want to get x by itself. We add 2 to both sides. Therefore, x is equal to 3 plus 2 is 5. And that's it. So the answer for this first example is x equals 5. Okay. We're going to do another example. We're going to do quite a few examples. These are not too hard. So here's another example. Let's say we have base, I don't know, 5 to the power of 2x, okay, is equal to 5. So I'm going to make this one uh, just a little more simplistic looking because some students tend to freak out when this happens. So just like we saw before, the bases are the same, okay? So bases are the same, so we're okay with that. So all we have to look at is the exponent. So you have the 2x, and then you have something over here, okay? But if there's nothing there, what does that mean? Okay, well, it doesn't mean that it's 0, okay? It means that there is a 1, okay? So there's always an imaginary 1 here, which means it's going to be 2x is equal to 1. And then just like before, we're going to solve. So in this case, we would divide by 2. So x is equal to 1/2 in this case. Okay, let's go ahead and do another example. I'll do that one right here. Let's do a base of 3. So we'll do 3 to the power of 2x minus 4 is equal to 3 to the power of x plus 7. And I'm just kind of making these numbers up, okay? So there's nothing particular about it. So just like the one before, again, my bases are the same. So all I'm going to look at is the exponents. Okay, and I chose this a little bit on purpose just to kind of see, so you see what happens when there's x on both sides. So I'm going to have 2x plus, I'm sorry, not plus, minus 2x minus 4, okay, that's a minus, is equal to x plus 7. Okay, and this is going to be a multi-step equation. So if I put my line, I'm trying to get the x by itself. So in this example, you can start wherever you want, but I'm going to start with the 4. So I'm going to do plus 4 to both sides, and that leaves me with 2x is equal to, let's see, 7 plus 4 is 11, okay? And then I'm going to try to get the x is all on one side. So since I already have 2x over here, I'm going to move this one. Remember, there's an imaginary 1 here. So minus 1x minus 1x, that goes away. Let's scroll down a bit. And 2x minus 1x is just 1x. So 2 minus 1 is 1, okay, is equal to 11. And at this point, I mean, we could divide by 1, but you should know that anything divided by 1 is the same thing. So x is just equal to 11. Okay, so it's just a matter of solving for x at this point. We could make it more difficult, of course. I could have made this a big number like 20x, but it's the same process. Okay, so let's go ahead and move on to another type of problem now. So that was with the same base. So now we're going to cover different bases. And it means exactly what the name implies. Okay, it means that the bases, those big numbers, are going to be different. So we're going to go right into an example. Okay, let's say we have 2 to the power of x plus 3 is equal to 8 to the power of, I'm going to say 2. Okay, so in this example, this base is 2 and this base is 8. So when this happens, we have to do two things. Okay, step one is we're going to rewrite the bases. Okay, so that they look the same. So in other words, we want both bases to be the same. Rewrite the bases to, I'm going to put this kind of in quotes, to look the same. Well, how do we do this? We can do this by using powers. Okay, by using powers. Okay, so usually what we're going to do is we're going to look at the smaller base. Okay, and I'm going to kind of highlight that. So we're going to look at this base and we're going to see if 8 can be written in terms of 2. In other words, can I write 8 as a power of 2? Okay, and you want to start with the smaller one because we can't do 2 in terms of 8. It's not going to work. Okay, so I'm going to erase what I just wrote, but you can copy it if you'd like. And I'm going to go ahead and just show you how I would do this. Okay, so 8 is the same as 4 times 2. Okay, so you see how we have a 2 already, but we need these to be just 2's. So I'm going to keep going. 4 is the same as 2 times 2. And if I bring that 2 down and keep the multiplication, we can see that 2 times 2 times 2 is equal to 8. So we can write this as a power of 2. How many 2's do we have? Well, we have 3 of them. So this is the same as 2 to the third power. Okay, so what I'm going to do is I'm going to replace this 8 with this 2 to the third power. And this is my rewrite. Okay, so the rewrite is going to look like this. 2 to the power of x plus 3, so that's the first, that's this one, equals 2 to the third, okay? And then because there is another power out here, I do have to put that out there. So that is still there. There's the square. So I replaced this box with this box, and now it's right here, okay? So that is step one. Step one is probably the most difficult step when it comes to solving with different bases, okay? Step two is to replace, so we just did that, replace the base. So we did that right here. And distribute. So this is kind of like step one, but it's all right. Distribute any powers. Okay, in other words, right here, we're going to distribute that. So this is our step two. Okay, this was step one, all this. Okay, so when we distribute that, this becomes 2 to the power of x plus 3. So the first one stays the same, equals, when we distribute power to power like this, you're just multiplying. So 2 times 3 is 6. So this is 2 to the power of 6. Okay. And step number 3 is to solve for x. I'm going to put normally. In other words, just like we did the first example. So just how we did these, if we look at this part right here, we have the same base now. We have a 2 and we have a 2. So we can go ahead and just look at the exponents. Okay, I'm going to put this as number 3. Okay, step 3. And we're going to solve. So x plus 3 equals 6. Solve for x. So let's see, minus 3, x is equal to 6 minus 3 is 3. That's it. So this is our answer for this equation. And if you wanted to check it, I'm not going to make you check it, but if I did require you to check it, okay, you would plug in the 3 right here and say, well, 3 plus 3 is 6, okay? 2 to the 6th power is, I believe it's 64, okay? And then 8 to the 2nd power, which is 8 times 8, is also 64. So, it would check out. Okay? Let's try another one of these, and then I think that'll probably be it, unless we have time for another one. So let's do another example with a different base. I might do one that's not too difficult, and then I'll do one that's a little bit difficult. Okay, so let's do 12 to the power of x minus 7 is equal to 144 square. Okay, so just like the one before, you can see that 12 is the smaller one, and 144 can be written as 12 times 12. Okay, so since we already have a 12 here, we're pretty much done. This is 12 square because there's two of them, 1, 2. So we're going to replace this 144 with this 12 square. Okay, so let me rewrite that. So here's my first one, 12 to the power of x minus 7 equals 12 square. So that's this part. Okay, and then we still have that 2 on the outside. Don't forget the outside exponent. Okay, so to the power of 2. Let me make that a little bit nicer. 2. Okay, and then we're going to distribute. So 2 to the 2nd power, okay, like this. And we rewrite this. So this is still the same. 12 to the power of x minus 7 is equal to 12 to the power of 2 times 2 is 4. Okay, and our bases are now the same. So there's a 12, there's a 12. All I need to look at is my exponent here, my powers. So we have x minus 7 is equal to 4. Okay, we solve for x, so we're going to add 7 to both sides, and that gives me x is equal to 11 in this case. Okay, let's do one more example. I'm going to do it right next to this. And this one's going to be a little bit complicated. So let's say we have something like this, 27 to the power of negative 3x, because why not? Okay, equals 81x plus Let's do 4. And I'm just making these up. Oh, sorry, 81. That's an 81. Okay. So in this one, we can do, let's see. You could solve it with the 27, but I'm gonna show you something a little bit different. Let's say you don't know what 81 is equal to. Well, we know it's 9 times 9, right? So let's start with that. Sometimes you might have to change both bases, okay? So we know this is 9 times 9. Now, 9 times 9 is not a 27. If I keep on going, let's say this way, well, that would be 3 times 3, okay? So you see how this is not matching. It's not matching the 27 at all. Okay, so what we're going to do then, we're going to say, well, let's see if I can change 27 to match something that we have over here. Okay, well, 27 is 9 times 3. Okay, so there's the 9. But remember that with bases, if you're going to rewrite it, it has to be the same number. So we can't have a 9 and a 3 here and then a 9 and a 9 over here. That doesn't make sense. They have to be all the same number. So we're going to keep on going. So this one is, let's see, 3 times 3, and then there's a 3. Hallelujah. There we go. We have all threes here and all threes here. So this example is kind of shows you something really important. If you cannot write one of them in terms of the other, you might have to change both of them, okay? So in this one, we're changing both bases, okay? Because otherwise it will not work out for us. Anyway, so this first one is 3 to the, let's see, there's 3 of them. So 3 to the third power. And this one, there's 4, so 3 to the fourth power. So just like before, we're going to replace 27 with 3 to the third and 81 with 3 to the fourth. So we have a double replacement. Okay, so let's try that out. So this is going to be 3 to the third, and I'm going to put that in parentheses because I still have an exponent here. So to the negative 3x. Okay, equals 3 to the fourth. I'm just bringing that down from here. Okay, to the power of x plus 4. Kind of got covered, but that was an x. Okay, so x plus 4. Okay, so again, I replaced 27 with 3 to the third, and I replaced 81 with 3 to the fourth. Okay, so now that we're at this part, we need to go ahead and do our distribution. So we're going to distribute this to this, so negative 3x times 3, and all of this to this. So this one's going to be a little bit tricky. We're going to write it out, though. It won't be too bad. Okay, so let's go ahead and do that. We're going to have 3 times negative 3x. So I'm looking at this part right here. Okay, and we're going to do it a little bit different just so you see it's a little bit easier this way. So 3 times negative 3x equals all this, 4 times x plus 4. So if you would like, you can also kind of skip a step. You see, I kind of skipped this one. I rewrote it and then I solved. This one, because I saw that there was multiple terms, I thought it might be easier just to kind of go right into the equation. Okay, so this is equal to this and we solve. So let's go ahead and solve this now. Let's say we're going to do, let's work on this side first. So 3 times negative 3 is negative 9x. Okay, now on the right side, we have to do a double distribution. So 4 times x is 4x. 4 times 4 is 16. And then we're going to go ahead and continue solving. So at this point, I would probably move the, let's see, the 4x. So minus 4x minus 4x. And I'm doing that because I already have I have a number over here. So I might as well just leave it there. So that's gone. Negative 9 minus 4, okay, is negative 13x equals, we're left with 16 over here. It looks like we're going to get a fraction. That's okay. We want to get the x by itself, so we're going to divide both sides by the number in front, which is negative 13. So that's gone. And I'm left with x is equal to negative 16 over 13. And you can leave it as a fraction as long as it is in simplified terms. Okay, and that's it. So if you have any questions, again, go ahead and please feel free to contact me. Hopefully this video cleared any misunderstandings you have about this topic.